Good afternoon. Can you hear me? My name is Andrea. Presently, I'm a consultant with Quantide, Milan. Quantide is a consulting company that provides a range of services to companies in the Milan area. We focus primarily on R and RStudio software. I am very pleased to have the opportunity to share with you an important topic relating to R programming. I consider this topic to be very important, but yet it is often ignored. I'm talking about automatic unit tests. Actually, pharma companies and car manufacturers must test before they can sell to customers. Our software should not be any different. I recommend that it should be necessary to have conclusive tests carried out before the integration with the corporate production system. And now to my first slide. I have selected Conway's Game of Life in order to demonstrate the importance of tests in development. But what is the Game of Life? The Game of Life is a cellular automation devised by the mathematician John Arthur Conway in the 1970s. To explain this, I'm going to start from the end. On the left-hand side, you can see the final result, the evolution of a system over time. In this picture, you are looking at a grid of quadrangles. The quadrangles can be black or white. What does this signify? If it is black, the cell is alive. If it is white, the cell is dead. Over time, this picture changes. Why? Because the system evolves. Evolution means applying 4 simple rules to each of these cells for each cycle. Now, on the right-hand side, you can see the 4 rules. Before moving on, you might ask, what is the definition of a rule? Each cell interacts with its 8 neighbors, and at each step in time, the following 4 transitions occur. Any live cell with fewer than 2 live neighbors dies, as if caused by underpopulation. Any live cell with 2 or 3 live neighbors survives to the next generation. Any live cell with more than 3 live neighbors dies, as if by overpopulation. Any dead cell with exactly 3 live neighbors becomes a live cell, as if by reproduction. Now I would like to implement the evolution of a single cell and, of course, test it. These rules are the requirements of the function identified as evolve. Therefore, the question could be, what does evolve take as input? It takes the present state of the considered cell and the number of its living neighbors, and then returns the new state of this cell. But why do tests? Tests are both validation tools and working documentation, and they also allow you to write readable and reusable code. Now we should test the evolution of a single cell performed by the function evolve. Therefore, we set up a test file and declare this context in the first line. The context is the evolution of a single cell. Each context is composed of several tests which validate the code in a particular situation. Here we have 4 particular situations, the 4 rules. Here we see the 3rd rule. Each test has a prose description and its code implementation. The former is representing the requirements, the latter an example of using the function we are developing. The implementation part is usually composed of 3 parts. In yellow, the initialization, which is where we set inputs and output of the tested function. In light blue, the function call, which is an example of a call of our code. And in blue, the validation of the outcome with the expected result. So in this case, we expect that the evolved state is equal to alive. Okay, the file we have seen in the previous slide is a documentation of the functionality developed. Because in this file, you will find the feature and some example of use of the function that clarify its operation. This is clearly a documentation. And now a question. Can this documentation become outdated? Of course not, because it is run every time with tests. For this reason, it is called working documentation. What do you think is important in writing code? Reliability, of course. And we have seen how to write tests in order to achieve it. But writing is an expensive task in terms of human time. Therefore, it is appreciated if it is reusable. How should a piece of code be reusable? Perhaps by a third party. It should be well thought out and readable. However, it's very difficult to write good code immediately. Therefore, it is important to have the opportunity to change how a functionality is written after having developed it. Let us look at the example. Here, you can see the if statement that has a complex condition. At this point, this code works. I have achieved the functionality. Maybe I have tested it manually many times. But now I would like to improve the format. Can I do this? I'm concerned that changing something means risking to compromise the validity of the original result. Because of if any changes are made to existing code, I run the risk of corrupting the original functionality. I would think twice before doing this. But this revision can be safely achieved using the refactoring method as alternative. Refactoring improves the code without adding further functionality. In this case, we can wrap the condition in a new function. The function is working time. And now the if statement on the right-hand side is self-explanatory. Nothing is changed in the functionality of our code. By not adding further functionality is an important part of this. In fact, if I refactor and the code passes the tests, this signifies that I have refactored correctly. This way, I can improve my code safely as much as I need to. After why do tests, we can speak about testing strategies. We essentially have two strategies for writing software with tests. The first is test-driven development, where test is a forerunner of the implementation. Test after development, where I can write the implementation and then the tests. Test-driven development is an approach to programming that involves writing tests before the implementation itself. So, the first step in this procedure is writing a test without having the functionality yet. Because this test represents the feature you want to add. In this case, the feature has not been implemented yet. Consequently, the test is going to fail. And if the test fails, you know that you need other changes in order to make it work, meaning you have to continue until it passes. But let's look at an example of use. Okay. Here we have the function evolve commented out. here the tests commented out. So we have nothing. Okay? On the right-hand side, we see that running the tests with a shortcut, we have no tests. So first of all, I write a test. I write a test and run a test. I got an error. Okay, an error is could not find function evolve. Of course not. There is no function evolve. So let's go to the code file and define an empty function evolve. I run the tests. Now I have always an error, but a different error. And the error is the evolve state not equal to that, where in the rule, any live cell with fewer than 2 live neighbors dies. So I have to implement this function, this feature. Okay, so I add if the number of neighbors less than 2 and the current state is alive, return dead. I run tests. Okay, it works. Okay, I'm sure of it. So I continue with all other tests, one by one or all in a row, it's up to you. I run tests. I got an error. I read the error. I implemented the needed function. I go on this way until we... Okay, Eureka, it works, okay? I have my functionality and my code is working. Okay, when the test succeeds, you have accomplished the task. The code works. So far, you have 2 channels. You have finished, or you can add another test to proceed. But this is a good point to start refactoring, because we are in a green zone, signifying that all tests are successful. This is mandatory. We cannot refactor if we are not in a green zone. I refactor. I run the tests. If some of them fail, I need to refactor better. If they succeed, I have 2 possibilities. Continue with the refactoring, or add another test and continue developing. Writing tests before the implementation, in this way, is useful because it forces you to design your code up front. But designing with tests is a very big topic for another talk. Next strategy, test after development. Sometimes we can't predict the result of a function, as it happens in the study of model, for example. In this case, we can use this different strategy. Under this scenario, I write implementation as I would usually do in the absence of tests, and only when the code is working, I write tests in order to validate the functionality. As you can understand, this method consists of the old way of operation plus tests. But now, what are the tools needed to apply those strategies? 2 packages, Testthat and Shinytest. Testthat is a complete set of testing tools by RStudio, and it is compatible with the different testing strategies, test after development and test-driven development. You have already seen Testthat in action in this slide, where in the first line the function context, in red the function Testthat, and in blue the function expect equal are a part of this suite. And finally, to Shiny. In order to test a Shiny application, we have to use test after development. Therefore, we already have a working Shiny application. We record a test using the application as the final user would do, so with the mouse interacting with widgets and plots. And then I can run these tests sequentially. If I change something, or I do refactor, and something go wrong, I am notified graphically. So here you can see the differences between the recorded run and the current one, colored out. On the left-hand side, you can see the differences in the data structure, data frame, lists, and so on. On the right-hand side, the difference in the screenshot on the web browser. I would like to conclude my presentation by asking and answering this very important question. Why are tests so important? As I have stated in my presentation, tests are significant in the validation process. In a way, tests are our safety net. They save valuable time by signaling that the process has been carried out successfully, or that we may have to go back to the drawing board to get it right. This is my message. I would like to thank you for your kind attention, and now I would be happy to answer a few questions.
Thank you, Andrea. And now it is question time. Just let's wave and I will run to you. Okay, then let me have the first question, Andrea. So the question is that you mentioned what is the difference between the test after and test driven, and you said that whether the output is predictable, that this should decide what kind of methodology you use. Are there any other factors or circumstances when you would rather say, oh, go with this approach, or oh no, you should use this one? And what I'm particularly interested is whether the organizational structure or the purpose of your software, or what could be important to in which direction should we start thinking?
I think that it's better to test upfront, because it helps you to make the design of your code. You start from the requirements, and then you code better. It's a matter of experience. I propose you to try, and you will see that your code will be written differently. In any case, you can't do that. You should take the second approach, so testing after development. Because testing after is always difficult, and it's often not done. So it's better to test up front, to do the design before, and to have tests that works.
Okay. One more. How long does it take, to force your people in your team to be that disciplined to start with the test? Because as far as I see, I don't know, in my previous organizations, we always knew what the nice and theory and the best practices are, and we've absolutely never used them because it wasn't the easiest path. And, there's always something which comes up and it seems more important or more urgent. What could I do to push my people into the right direction?
Okay, at the beginning is a little weird to start writing tests because you don't know how to do. But usually I suggest to start with a simple exercise like the game of life to try it. And then when results come out, so you can write a good code, you can refactor. Refactor is very useful. It allows you to write readable code that also your colleague can read, and also your colleague can see the example in the test file, and this is good to apply this strategy.
Okay, I will let you know how it went.
Okay.
I will look back to the audience. Absolutely.
Thanks for the speech. I'd like to ask about that Shinytest, because I think it's still on GitHub only, and not is on CRAN yet. Have you got a chance to use it in terms of continuous integration? Does it work in, for example, deployed Docker container or on Travis, for example?
Okay, it works. I haven't used Shinytest in production, in continuous integration right now, but I'm sure it works because I've tested it. It's not that complete as a package because it allows you to test and to have information on the server-side part. So what happened on the server side, but not in the front end. So it cannot memorize what happened in the web browser.
Okay. So it's a bit different than Selenium.
There are other approaches like with Selenium, but they are more complicated, but somebody used them.
Okay, thank you.
Yeah, I get it back. I'm so sorry, Andrea. I ran out of time.